Hi, I'm Ross Curtis with Ancestry DNA Science Team. Today, I'd like to talk about how we find matches that are meaningful for genealogy. Like you all know, we inherit DNA from our ancestors, half from mom and half from dad, and our parents inherited DNA from their ancestors. Some of the DNA we inherit from our ancestors is shared with other descendants. We call this matching DNA. Finding matching DNA between two individuals is super helpful when we're doing our genealogy. But not all the DNA we share with others has been inherited from a common ancestor. Population geneticists have known this for a long time. They've named DNA that is shared because it was inherited from a recent ancestor IBD, or identity by descent. DNA that is shared for another reason is called identity by state, or IBS. If a DNA segment is common in the world, or in a certain population, it can be shared between a lot of people who aren't closely related. Let's look at an analogy to illustrate this. Let's say we're comparing the text of a lot of different passages. We want to find which passages are from the same sources. In this simple example, we'll just use these 4 example excerpts. When we compare these excerpts, we find that all 4 of them contain the phrase, "the boy ran." This phrase might have the same source that contributed to all these passages, or it could just be a really common phrase that is part of a lot of books. Maybe you've even read passages with this phrase before. Just because all these passages have this common phrase, it doesn't mean that they all have come from the same original source. When we compare more of the passages, we find more matching phrases between 1 and 4. The longer match helps us to be more confident that these excerpts are from the same source. Now let's make this example look a little more like the chromosomes we've been talking about with DNA. You can see that all 4 of these phrases match at the same blue segment, "the boy ran," but that 1 and 4 have matches at the green segments too. We can visualize this like this, where we're counting the number of times a phrase is shared. If we were to look at 1,000 more passages, we might find more times when the phrase, "the boy ran," is used. The green segments probably won't be found in other passages. This gives us confidence that the common phrase, "the boy ran," probably didn't originate from the same source for all of the passages. However, segment 4 probably is a true match to 1 because the matching phrases are long and rare. This example is, of course, contrived, but in Ancestry DNA, we use an algorithm called Timber to do the same thing with DNA matches. We match you against our entire database with millions of people to see how often you match on each segment in your genome. Sometimes you match just a few people on a segment. Sometimes you match hundreds or thousands of people. Based on how DNA is inherited, we can be confident that common segments are probably not inherited due to recent ancestors. The plot on this slide looks a little different than the one we've been looking at on the past few slides, but it is showing the same type of data. Each dot is the number of matches that are shared with this customer at a particular segment. The plot runs across the customer's 22 chromosomes. If we zoom into this example customer's plot, we can see that there are some of these huge peaks. On chromosome 10, 8, and 6, for example. If we were to deliver all these matches, customers would see thousands of matches that are not related to them due to a recent ancestor. Fortunately, Timber removes matches on common short segments. That means you can put your focus on those matches that are most likely relevant to your genealogy. Thanks for watching.